Hello students, how are you? I hope all will be good. So today I will discuss with you a small concept and very important pure rolling, which is the concept of chapter rotational motion. So topic is pure rolling. Okay, pure 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 rolling, pure rolling. So what is the meaning of pure rolling? So before before pure rolling, we have to understand the concept of rolling. What is the rolling? So my dear, look at a board. Look at a board. What is the rolling? Suppose we have a wheel of a car like that. Wheel of a car. So if you see the wheel of a car, the wheel is in a rolling motion. Why motion of wheel is called rolling motion? Because the wheel is doing rotatory motion with angular speed omega. Along with that, wheel is also moving in forward direction. So it is have linear velocity also. So suppose the wheel have linear speed v. So you can see here the wheel of a car basically have two motion. One is rotatory motion and one is linear motion. So linear motion speed is called v and angular speed is called omega. Now the wheel, now we can see here the wheel basically have two type of motion: translational translational plus rotation. Translation plus rotation. Translation plus rotation. And the combine of these we called rolling motion. Combined motion of this is called rolling motion. Rolling motion. So before pure rolling, we should have and learn the concept of rolling. So what is the meaning of rolling? Suppose we take example of a car, wheel of a car, which have linear speed v and angular speed omega. Due to angular speed, we can say it has the rotation motion, and due to linear motion, we can say it is a translatory motion. So combination of this motion, we should say rolling motion. So rolling means what? Rolling means combination of linear plus rotation. Linear plus rotation is called rolling motion. So this is a basic practical example of wheel of a car. Now we understand the what is the mechanics of pure rolling. So before pure rolling, it was must we have to know what is about rolling. So in next slide we see what is the concept of pure rolling. Okay, so see here, what is the mean pure rolling? Suppose we already take example of wheel of a car which is moving at a platform. Suppose a wheel is moving on a surface, and this surface we can see surface 2, and the point of contact we can see at point of contact we can say the point 1. So pure rolling is basically applied at a point of contact. What is the point of contact? Point of contact is this part where the lower point of wheel is touched with surface of a platform. So we focus at this part. So what is a pure rolling? So pure rolling means for a rigid body. First we have to know the concept is valid for a rigid body. So for a rigid body at point of contact, at point of contact, relative motion should be zero. relative motion should be 0. You get my point? Relative motion should be 0 at point of contact. So, my dear, look at a board. We see what is the mechanics of this part. So, if I zoom this part, so it is look like that. The point 1 is for a wheel, and the platform I draw this with different color. This is the platform. So if we separate the contact point, this is the point 1 and this is the point 2. Because platform at a rest condition, so if wheel is doing rolling motion, so it is have both speed, linear and angular. So at a point of contact, if we draw the mechanics of the velocity, so point 1 have linear speed v and the speed is r omega. Linear speed v and speed r omega. At point 2, because platform already at a rest condition, my dear, so the velocity of point 2, the velocity of platform 2 will be 0. First we understand what is the mechanics at a contact point, then I will come again on a definition and we understand with this diagram. Okay, so I write in a definition. First, the pure rolling is a concept valid for a rigid body, and at a point of contact, relative motion should be 0. What is the rigid body meaning? Rigid body means the distance between any 2 points for a body, if is not changed, then this body is called rigid body. So for rigid body, at point of contact, relative motion should be 0. So what is the meaning of relative motion should be 0? Relative motion should be 0 means the velocity at point 1 and velocity at point 2, the difference should be equal to 0. So this is the condition for a pure rolling. V1 speed of a wheel and V2 speed of a platform. So V1 minus V2 equal to 0. We can apply this. So point 1 have a net speed V1 बराबर equal to V minus R omega. V1 equal to V minus R omega and V2 already given 0 because platform at a rest condition. If we apply the condition in this part, so we can write here V minus R omega minus V2 already 0 equal to 0. So we can see here V बराबर R omega. V बराबर R omega. V बराबर R omega. So when we understand the concept and see what is the pure rolling, so pure rolling means at a point of contact, the relative motion should be 0. Relative motion should be 0. So this is the condition for pure rolling, and because both velocity at a point of contact is equal, so we can also write here concept of, we can say also the concept of no slipping. So pure rolling also know with this concept no slipping. So what is the meaning of no slipping? The relative motion should be 0 at point of contact and V equal to R omega. But the important part is this: if V बराबर R omega, this is not 100% pure condition for a pure rolling. It is only valid when the platform at a rest. If platform is moving with some speed, then we cannot write here V बराबर R omega. So because platform speed also include in R omega, then V equal to R omega plus V naught, R omega minus V naught. It is depend platform is moving in right or left direction. So this is the one part we can say V बराबर R omega. Okay. अब V1 अच्छा relative motion V1 and V2 बराबर 0. So this is called no slipping. Okay. Now if we consider the platform is moving with speed, suppose this is the wheel and this is the platform, wheel and platform. Suppose at point of contact, platform also moving with speed V naught. Platform also moving with speed V naught. So at a point of contact, if I draw this again, so this is the point 1, this is the point 2, point 1 and point 2. But this time platform also moving with speed V naught. And point 1 have linear speed V and this is the tangent R omega. Why R omega on left side? Because I consider the wheel is moving in clockwise direction. clockwise direction omega. Okay. Now, if we apply the condition of pure rolling, what is the condition for pure rolling? Relative motion should be 0. So, speed of V1 should be equal to V2. So, what is the V1? V minus R omega. Why we consider the V positive and R omega negative? Because right side I consider positive, left side consider negative. So, V minus R omega equal to speed of platform which is equal to V naught. So, what is the V? V बराबर V naught plus R omega. V naught plus R omega. So, we can see the concept of V बराबर V naught plus R omega. So if platform have a some speed V naught, then pure rolling condition is not V बराबर R omega, it is V बराबर V naught plus R omega. Okay, so we revise this again. Here I make a diagram. This is the wheel of a car. At point of contact, there is 2 points, point 1 and point 2. Point 1 include in a wheel at a contact point, and point 2 is a platform, which is a rest condition. So what is the condition for pure rolling? At point of contact, relative motion should be 0. So if we do the joule part of the contact point, we separate the both things 1 and 2. So point 1 V and this one is R omega, and point 2 is V2 equal to 0 because platform I consider the rest condition. So what is the net speed of V1? V1 have a net speed at point 1 V minus R omega. Right side consider the positive, left side consider the negative, and V2 is already at a rest, so V2 equal to 0. So V1 and V2 बराबर equal to 0 because at point of contact net speed is 0. So this is also the condition is called no slipping, or we can say pure rolling, both are the same. So I put the values here, V minus R omega 0 equal to 0. So we find out V बराबर R omega, but this is already valid when a platform at a rest condition. If platform is moving, so I explain here, if platform is moving at a point of contact, the speed will be same V minus R omega, but I change on a platform speed, it is now V naught. So V minus R omega बराबर V naught and V बराबर V naught plus R omega. So this is both condition for a pure rolling platform when platform is moved and platform is not moved. Okay. Now, okay, we see one more condition. What is that? So if I write here naught point, so what is the naught point? Naught point is it when V equal to R omega, V बराबर R omega, V equal to R omega. What is the meaning? Meaning is that it is a pure rolling. Pure rolling. Pure rolling means no slipping. Pure rolling means no slipping. No slipping. No slipping. No slipping. Okay. For a no slipping condition, V बराबर R omega. If linear speed is greater as compared to R omega, if this will be happen, so we can see here, if V greater than R omega, then linear speed is more and rotating speed is less. So this is called forward slipping. This is called forward slipping. Forward slipping. Forward slipping. Forward slipping. If, okay, before write the third point, I again connect this all concept with the practical things. Because at a point of contact, pure rolling is act, means relative motion is 0. So this is the reason why wheel of a car can move and not rough in minimum time. Okay. So if a wheel of a car at a rough condition or we have to require to change, then it is due to the slipping. When V greater than R omega, then it is called forward slipping. And if V less than R omega, basically V greater than R omega condition we can see when we apply the brake suddenly on a car, then wheel will be skid on a surface. Then linear speed is more, R omega is less. So this is called forward slipping. What is the V less than R omega? It is called backward slipping. So what is the practical example of V less than R omega? Here R omega is more and V is less. Suppose wheel of a car is in a mud. So if you again see the wheel, the wheel is only rotating. It's not going back and not going forward direction. So if V less than R omega, then this is called backward slipping. Backward slipping. Backward slipping. Backward. Okay. So we write here basically 3 points: V बराबर R omega, V greater than R omega, and V less than R omega. Okay. One more important point we should write here. We should write here. Okay. One more point, which is a point 4. I am writing here. In pure rolling and in a rolling motion, one point should be remembered, that the point of center of mass, point of center of mass. So we should remember, my dear, point of center of mass always have only translatory motion. Only translatory motion. Look at a board, my dear. Point of center of mass always have only translatory motion. If I go back the two diagram which I draw here in first one, okay, this one, the diagram, okay, yeah, this diagram. Here you can see in a wheel, this is the linear speed V and rotating speed omega. My dear, you should be remembered that this linear speed V is speed of center of mass. This linear speed V is for center of mass, and this linear speed is valid for all points but only for the linear motion. Suppose center of mass have a speed V. If I take a point and a circumference like that, and I take point in a middle, suppose this general point, so both points, if the wheel have infinite number of points, and this infinite number of points have a same linear speed V, because the speed of center of mass is valid for all points only, but only for linear velocity. But rotating speed V बराबर R omega, when I write the condition R omega, then R omega is different at different point along with direction. Because V बराबर R omega means the condition of pure rolling R omega is depend omega and distance R. If R is different from the center, then R omega is different. So you have to remember the center of mass only have the linear motion, not a rotating motion, and the linear speed of center of mass is valid for all points, but omega are different at different point with direction. Okay, now with this concept we solve a simple question which is also asked in a JEE. Okay, suppose, okay, V बराबर R omega. So same point I write here. You can see here the point of center of mass always have a only translatory motion, not rotating motion. Now we come and solve a simple question which is also asked in a question JEE. So what is the question? Question is that suppose I have a wheel and by default we always consider platform at a rest. So by default we consider condition of pure rolling V बराबर R omega until unless he is mentioned in a question platform is also moving. So by default we consider platform at a rest and apply the condition V बराबर R omega. So here is a wheel which have a radius R. On a wheel, my dear, I consider 4 different points. Here point A, here point B, here point C, and here point D. The question is asked, arrange the net speed A, B, C, D, net velocity in a decreasing or increasing order. This 4 point A, B, C, or D. And pure condition is applied. Or in question it is already mentioned no slipping. What is the meaning of no slipping? No slipping means pure rolling, platform at a rest. So my dear, we can use the condition V बराबर R omega. So how first, if we write a net speed at any point on a wheel, we should first draw the simple mechanics or simple FBD about A, B, C or D point. So what is the FBD? If I draw or I make net speed diagram. So point A, because center of mass have speed V and rotating speed I consider omega, and wheel is rotating in clockwise direction. So at a point, if you see here, so point 1 here have a linear speed V because it is the speed of center of mass. The direction will be same and magnitude will be same. And because it is rotating in a clockwise direction, so at a point 1 we can draw the tangent and we can write here r omega. Because the wheel is going in clockwise direction, so if I draw at point A r omega due to rotating speed, then it is r omega in rightward direction and v is 0. So what is the net speed point A? Point A net speed equal to r omega plus v. And because pure rolling is applicable at this condition, so r omega we can write equal to v. So net speed is equal to v plus v, and it will be equal to 2v. V equal to 2v. Okay. Now if I draw that video point V, so linear speed will be same, and because it is moving in a clockwise direction, so r omega should be here. So net speed is passed through at this. We can write here it is Vv. So what is the Vv? And because r omega is equal to V, because pure condition is applied, pure rolling condition is applicable, so we can write here Vv barabar under root V square plus V square. So it is the net speed equal to V under root 2. Or we can write here at a vector condition also. We can write in a vector form Vb barabar Vbb equal to V I cap minus V j cap. Or we can write here, if you can write here Vi cap or minus r omega j cap. Vi cap minus r omega j cap. So my dear, look at a board. At a point A, V linear speed. Due to rotating, we can draw a tangent r omega. Because pure rolling is applicable, V barabar r omega. So we can write here net speed because both have the same direction. V r omega plus V, and V plus V equal to 2V. Or we can here write it a vector form. What is the vector form? Vector form we can write here V I cap plus r omega also I cap. V I cap and also write a r omega I cap. Okay, this is the net speed of point A. What is about the point B? Point B have a linear speed V, and in downward direction it is at r omega downward direction. So net speed will be equal to V square plus V square V root 2. So Vv barabar Vi cap minus r omega j cap. Okay, the same condition is applicable for point C. So if I draw a diagram, draw the FBD at point C, we can see here V applicable is here, speed V, and tangent is draw here r omega. So what is the net speed? What is net speed at point C? So we can write here at point C vector form Vc barabar V I cap or minus r omega I cap. This is the vector form. So what is the net speed? Net speed we can write here Vc equal to V minus V, because r omega is also equal to V, pure rolling is applicable. So net speed at point C will be equal to 0. So we can write here the point C is look like at a rest condition. My dear, this is a very important concept because at point C the relative motion should be 0. We already discussed this thing, because point 1 for a wheel and point 2 for a platform, at a point of contact there is no relative motion. So this point, the wheel, the contact point with the surface, it is look like a rest condition. We can see here by mathematical Vc equal to V minus V equal to 0. Okay, so this is about the point C. Now if I discuss about point D, so if I make a velocity diagram for point D, so you can see here the D point linear speed have V, the same concept is applicable, and upper direction we can write here r omega. So what is the net speed? Net we can write here point D. Point. So we can draw this velocity basically. Speed if fall, then this is only about the magnitude. If you include I or J, means it is talk about the velocity. Okay. So the velocity vector Vd here, V the r omega of in J direction. So if I write the net speed at point D, so we can mention here point D. So we can write here vector form Vd equal to V I cap plus R omega j cap, r omega j cap. So my dear, at point D, we can write the net speed under root v square, because r omega is already equal to v, then equal to v square. So net speed, it will becomes out v root 2, v root 2. So by solving this question and pure condition is applicable, we can see here the point A have net speed 2v, and if you look my dear, the point B and point D have a same speed, root 2v and root 2v, and point C, because pure condition is applicable, pure rolling condition is applicable, so point C look like a rest and net speed will be 0. If I arrange the 4 point in a simple decreasing or increasing order, so we can write here, because we can see point A have net speed 2v, point B and point D both have equal speed v root 2, and point C equal to speed 0. Okay, so net speed 2v, v root 2 and 0. So if I arrange the decreasing order, so we can see the point A have a larger speed, point A, and it is less than B and D, because both have the same speed, B equal to Vd, and the less order it will be point C, because point C at a rest condition, so net speed at point C is 0. So this is your question, answer of the question, the decreasing order of a speed at a point A, B, C or D. Okay, so this is a simple question. We can see here again, which I draw here diagram, the FBD, we can say the speed diagram A, B, C and D. Okay, now we discuss one more question which is related to the pure rolling. Okay, so suppose question is that, so we have this time we have the two platform. Suppose we have a two platform like this, and one platform is here. We have a two platform, and between that I draw a wheel which is doing rolling motion. Rolling means center of mass have speed v, and again I consider this clockwise speed omega. This is the center of mass, omega. Okay, so this is called speed given v naught. This is given v naught, and we can see here two platform basically, platform 1 and platform 2. Both platform are moving. The platform 2 is moving with linear speed 5v, and platform 2 is moving in a backward direction with speed 3. Okay, you can see the question. The one wheel which is not pure rolling condition, pure rolling is given. Pure rolling means v naught barabar r omega. We can write here for a wheel v naught barabar or v naught equal to r omega. So platform 1 is moving backward in left side with speed 3v, and platform 2 is moving forward with the speed 5v, and wheel is doing pure rolling motion. So center of mass have a speed v naught, and this is omega. So at a point, question is that find the value of v naught. Find value of v naught. Find the value of v naught. I think take a time and you should try the question, and after that we will discuss here. Okay, I hope you will be trying. Okay, so we discuss here question. What is the solution of that? Look here. Here you can see basically two contact point. One is this, I can say point A contact point, and this one I can say contact point B, because if we apply the condition of pure rolling, we take always the contact point. So this is the contact point A and contact point B. So if we write the equation, if I write the equation at a both point, what is the equation? So at point A, okay, at point A, what is the equation of point A? So point A, you can say at the point A, speed is V naught here for a wheel, and R omega is act in a leftward direction. So V naught act in the rightward and R omega in leftward. And both speed should be equal. This is the condition of pure rolling. At a point of contact, wheel and platform both should have the equal speed. So point A we can write here net speed V naught minus R omega. V naught minus R omega is equal to, this is the speed of point A, is the point of a wheel, and platform speed equal to 5V. We can see equation number 1. V naught minus R omega barabar 5V. Now if I focus at point B, focus at point B, my dear, focus at point B. So at point B you can see V naught speed like that, because linear speed always act in the same direction, is the speed same of center of mass, and because the wheel is rotating in clockwise direction, so R omega also act in a same direction, and again we can apply at a point of contact, platform and a wheel both have the same speed. So at point B you can see V naught R omega in a rightward direction, so I can write here V naught plus R omega equal to, because platform is moving in leftward direction 3V, so we can write here minus 3V. Minus also we should act here, so we can write the equation like that at point A and point B. So point A V naught minus R omega barabar 5V equal to 5V, and V naught plus R omega is equal to minus 3 into V. Now we can solve the equation and find the value of V naught. So we can add the both equation. Okay, so we see what is the solution of that. So equation 1 plus equation 2. If I add the both equations, so it is equal to 2V naught, because R omega cancel out, and it is equal to 2V. So 2 cancel. So speed V naught is equal to V. So this is the solution of the question. So first I discuss what is the concept of pure rolling, and based of that I discuss the two questions, both question asked in a JEE. Okay, so this is the answer, V naught equal to V. So after the concept of pure rolling, now I discuss here the one question which is asked in a JEE Advanced 2020. Okay, you can see here a football is fit in a pit, have a distance 2r, radius of football is capital R, inclined plane have an angle theta. So my dear, the small r is less than capital R. One end of the plank is now lifted so that football get tilt. So we have to find the maximum value of theta so that football does not start rolling, means football should not be comes out from this pit. So we can see here the football should not be roll about this point. We have to focus this point. Football should not be roll about this point. Okay, now if I draw the diagram of football, means simple geometry. So if I draw a circle like that, okay, circle like that. Now if I draw diagram, so this is the center point, means mg of football like that. I make a BD of football. I focus on a football, make a BD which have radius capital R, mg like that, and I draw one line here and one line here. This. Okay. So mass of football I consider m. So mg will be act downward, and by geometry, if the inclined plane have an angle theta, then this angle should be equal to theta. This angle should be equal to theta. After that, I do the component of mg. Then this will be mg cos theta, and this will be mg sin theta. I am not considering the normal reaction. Why? Because when football try to roll here, then for a maximum condition for theta, then this point contact will be loose. and at this condition the normal reaction will be 0. Normal reaction will be 0. So I am not considering here the normal reaction, only consider the mg. Okay, mg here cos theta or sin theta. Now if you see the distance, this is a 2r from this distance, and I draw here, so it is look like that. This is the distance small r, small r. Okay, so this is the distance small r, means this is complete 2r and mg act here. So this will be half considered 2r till the distance r. So I consider this r. So and this distance, it is the radius of football. It is always be capital R, because from the center at the circumference all the distance will be the same, radius will be the same. So this is the r, this is a small r, angle theta or mg cos theta. And football should not be roll out about this point. Means if I consider maximum value theta, so that football does not start rolling down from the plank. So I have to do the torque should be equal to 0. Torque should be equal to 0. First we see at the triangle here, this is a distance r, this is capital R, angle theta. So this distance will be comes out under root r square minus small r square. R square minus small r square. This is the distance. So if I take torque, means if maximum value theta and football does not rolling down, so torque should be equal to 0. Torque should be equal to 0. Torque should be equal to 0. Okay. Torque should be equal to 0 about this point, which has considered the distance r. About this point, torque should be equal to 0. If you compare both diagram, you will find this point here and this point here. This point here. Okay. So torque should be 0. So now, what is the force? Mg, we have the two component, mg sin theta, mg cos theta. So what is the torque about mg sin theta? So mg sin theta make torque about this. This is the force and this is the perpendicular distance. So what is the torque? Force mg sin theta, mg sin theta, and perpendicular distance under root r square minus small r square. R square minus small r square. Okay. Small r square. Okay. Now minus small r square. So this is the torque of component mg sin theta about this bottom point, about this point. Now we also have a one component mg cos theta. So what is the torque about for mg cos theta about this point? The mg cos theta into perpendicular distance small r. So mg sin theta about this point make a torque in a clockwise direction. You can see here, if I keep this point and rotate about this, it will be clockwise. And if I consider mg cos theta about this point, it will make anti-clockwise. So clockwise I consider positive torque and anti-clockwise consider negative torque. So this will be clockwise, I consider positive, then minus, you can see here mg cos theta perpendicular distance r. So minus, I write here mg, I already mentioned minus sign, mg cos theta into small r equal to 0. This will be the net torque. So if you see here, both values should be equal. Mg cos theta under root r square minus small r square r square minus small r square, and this will be, again I can write here, this is the mg sin theta, So this value, this mg sin theta root r square is, and this value, it will be equal to positive mg cos theta into small r, mg cos theta into small r, Okay. Now mg cancel out, mg cancel out. So sin theta by cos theta will be equal to sin theta by cos theta will be equal to a small r divided by under root r square minus a small r square, and this sin theta upon cos theta a small r divided by this. So we can write this sin theta by cos theta equal to tan theta. So tan theta बराबर या tan theta equal to r upon under root r square minus small r square. This is the tan theta. Is a tan theta. But if I check the option, tan theta is not mentioned in for option r upon under root r square minus r square. So according to option, I make a simple diagram here. We can draw this. You make the geometry of this tan theta like this. So if this angle is theta, what is the tan theta? Perpendicular upon base. So this is the perpendicular, this is the base, under root r square minus r square, and by geometry we know, okay, by geometry we know if this r and this under root r square minus small r square, this one will be r, this one will be r. So now if I write here sin theta, it will be comes out, sin theta will be perpendicular upon hypotenuse, any small r perpendicular, and this will be small r by capital. Okay, now if you write cos theta, what is the cos theta? Base upon means under root r square minus small r square divided by capital R. This will be cos theta. So basically I write three values, sin theta, cos theta and tan theta, and do a torque zero about the contact point. So now we can see the option, which one will be correct. So again, okay, now this is the question. So you can see here, tan theta is not correct answer, not match. Okay, tan theta r by capital R, not small r by 2r, and cos theta is not r by. So correct option is option number A, tan theta equal to small r by capital. So thank you so much.